All right, let's go here. And this is going to be kind of a cool demo. I'm going to do this every couple weeks. I'm going to keep moving on AWS, but programmatically, but with the Rust language. So what I'm going to do today is I have a repo called Nogi Rust MLOps template, and there's actually already a bunch of AWS stuff in here if you want to fork it. But I'm going to click on this code button right here, and I'm going to open up code spaces. So a couple of things I'll point out that is nice about the code spaces environment here is that I was able to install this tool right here. This is AWS tool, and so it really acts a lot like AWS Cloud 9, but I get to use my favorite a code generator, which is Copilot. And so if I go through here and I take a look and I look at S3, for example, right, you can see that this is hooked up. So really the place that I think would be a fun place to start off with is to dive back into Lambda a little bit. And I've actually been playing around with Lambda and Rust, and it's just amazing. So a couple things though to take away is one of them is that it probably is a good idea to have a virtual environment initially, even though it's a Rust thing. If I go to source env here, I have a virtual environment that I use when I'm working on something that requires a little bit of Python. So I'm just going to put this in my bash RC here. So this will just make it so that I can just for once and finally just get this activated every time I'm in here. Okay, so I got that solved. Now the next thing that we'll need to do is a couple different things. One is let's look at the REST AWS bindings here. And so this is one of the things that's kind of interesting is we can see that in fact they're still in developer preview, I believe, but I've been playing around with them and they work pretty well. And I'm going to go to GitHub and you can see this is where it's at, AWS SDK Rust. And we can see that this SDK is currently being released as developer preview. So hopefully it gets finalized soon, but I've had pretty good experience actually playing around with this repo. So here's one of the resources that we can use. And so what I'm going to do is I'll go to this repo here and I'm going to put a section. I think I already have an AWS section here. And here we go. So I'm going to say like, it's resources you may care about, resources you may care about. Here we go. We'll put this in there. I'll check these in at the end so that people can get access to them. And we do that. Here we go. And the other one that I'm gonna dive into today is Rust Lambda, which is really cool. And I've had some fun times playing around with this inside of this repo here. And we can say Rust Lambda. So Rust Lambda is pretty awesome for many reasons. So let's start off though with the fun stuff. So let's today build a Rust Lambda here. And so if we look at this package here, a couple things to be aware of is that if you wanted to do this on OS 10, you just have to brew install cargo Lambda. Windows uses Scoop. I've never actually used that before. And then again, this is why I actually invoked Python, which is a little annoying. I'm get annoyed now at using Python virtual environments, but I did it. I installed a cargo Lambda right here. So that's really step one is, I'll just put a link to this is install the cargo Lambda. So we'll say here, if we want to do it, step one is install cargo Lambda and source environment. Right, so we've got that. So I already have that, and if I just type in pip freeze, for example, and I say grep Lambda There we go, cargo Lambda, right? You can, and this is probably a good thing to let people know about is like, hey, check to to verify it is installed. Do this. So do that command. So I got it verified. So now it's going to be pretty easy. We just have to do that. We just have to say cargo new, and it'll build out a structure for us. So this is what's different about Python versus Rust is that the cargo system is just, I would say, I don't know, 100 times better than Python packaging because it gives you a one-shop tool that does pretty much anything you need to do to write good software. Where Python is, who knows, you can install this tool, that tool. There's no uniform way to do things. So if we go through here, we type in cargo new. Other thing that I'm gonna do is call this some, like, what would be kind of a cool one to build? I would say, let me see, what kind of let's do like a random, let's see, I want to pass something in that's kind of fun. Um, maybe like a meal generator. Let's do that. So let's say meal gen, and now it's going to ask me some questions. So it's going to say, is this an HTTP function? If you do yes, then it'll set up the load balancer for us. I don't want to deal with that, so I'm just going to say no, leave the defaults. And then it, like, do you want like special events, for example, CloudWatch logs, timers, etc. I don't care about any of that. I just want simple Lambda. So now I'm going to go into MealGen here, and so I'm gonna put this step right here. We'll do this, and then cd into MealGen. We don't need to do cargo in it. We already did cargo. So what I like to do, and I would recommend that you do, is to actually have a makefile when you work on a project, in my opinion. So I have that Marco Polo Lambda. I think I have a makefile in there. Yeah, so we could just copy that one. For example, I'm going to go here. And the reason why a makefile is super helpful is that it just keeps track of annoying things, right? And then I'm also probably would say like a README, you know, you know, if you needed to have extra notes or something. But in general, the most important one is probably the makefile here. So again, I copy this. Let's just go to our makefile in MealGen. And this will need to change a little bit, but I can come back to it. But the idea here is that if I go into the cargo file, this is where I would keep the namespace. So if I was going to create a library or something, I would have to use that namespace to refer to a lib.rs. And then I also have my dependencies. So we see Lambda runtime. It's got the Tokyo library, which is this super powerful async. And it also does all this tracing, which is really cool, actually, that you can trace your logs. I mean, you can trace your application and see all the different things that are happening inside of it. So it's really set up exactly the way you'd want it to be set up. And if we go to the main here, it gives you like a boilerplate start here. And so this is just a made up example. So I think the first thing that I would recommend is just this, there's so much boilerplate stuff here that it actually makes it look more complex than it is. So just remove this and just remove this. So this is the function handler. So in Python, it looks pretty similar, right? This is the handler here. And then this is a required component that is just part of Rust, right? Rust always requires a main function, and in this case, we want to say the main is going to be async. And so this is, you don't really need to care about it. This is it. That's the only thing you really need to care about, unless you want to build some other, piece of code that gets invoked inside of here. But what will be kind of fun is to build out something that's somewhat useful inside of this Lambda function and deploy it. So what I'll do first here is I like to recommend a style of development, and I'll go through here and I'll say this is the style I recommend, which is step one to develop robust Rust code, recommend doing the following. Step one, I would say create a good comment for Copilot. Two, run make lint, make format, run make format, make format. And the idea here is that when you format your code, you're actually cleaning up things in a way so that Copilot is even smarter. And then I would do run make lint, and then I would run, make run. So basically, you essentially format it, lint it, run it. And this is often a really good, scenario to build out Rust code. So that's what we're going to do. So the first thing we'll do is we'll say, um, basically, does anything work? So we'll list if I do a lint, does that work? And this is going to take a second to install all the packages. So give this a second. And while this is installing the packages, what I can do is we see this example. If you already have you can just do build release and I'll deploy it. One of the other things that's kind of cool is that you can release ARM64, which is pretty slick, which means that you can use the lower cost compute. I forget how much cheaper it is, but I think it is cheaper. And you also, if you want to deploy this binary to AWS, you just go through there and deploy it. I don't see how you deploy, like, to test it locally. I don't know exactly how you would test it locally, but whether it's different than this, but you can actually invoke it once you deploy it. So let's double check here. Okay, so lint passed, right? So of course, we expected that. So now let's make something. Let's make like a function that returns back some fruit or something like that. So we'll say like here, create a um, function that turns back a random fruit. And so we again kind of seed this together here, and the idea here is that you then take a look and see if it's actually what you care about. And let's look at the code here. So what do we got here? So we have basically a vector that includes a apple, banana, cherry, durian, elderberry, and then we say this random. Now I don't remember if random is an import. We're about to find out. So I'll format it. Right. So let's do make format first. Let's do make lint, and we're about to find out if yeah. So undeclared module. So I believe all we have to do is go to cargo rand, import the rand, right? And so this shows you how trivial it is to tweak things inside of Rust, right? It doesn't look that much different than Python. Okay, so it's dead code because we haven't invoked it yet. So we can say we can put a little bit of logic here, and what we can say is basically we can say this would be the name. We can even call this the meal. Let's say meal. We'll call that event.payload.meal. We can say meal. We can say like meal. Let meal. So check some useful info, and we can say like if meal if the meal is equal to breakfast, lunch, breakfast or lunch, return a random fruit. Otherwise, return steak. Yeah, we'll do something like that. So we'll say let meal match meal breakfast to string. So here we can use our other function over here, and we can say let meal, and then what we can do is breakfast. If the meal is breakfast or lunch, let's do that. So let's do this breakfast, lunch, steak. That looks pretty good. I think this will work. So now we want to format it. So let's go ahead and make format. There you go. So formatting works. Let's go ahead and lint it. Okay, no field meal on request. And let meal equals event up payload. Let me look at what I did before here. Let me look at my other. So I had a Marco Polo Lambda before. What did I do? So I said name. So where did I got to put it's the struct up here. That's the problem. Okay, so I had to go back up here and see. Look, I put this as command. We need to change that to meal. There we go. So the nice thing about the compiler here is, boy, it really kind of keeps you on your toes, and it really catches bugs that a normal language would have a problem with. And we can say this expression expected structs. So what we can do is not and found string. So we can even ask it to do that, right? So we could say that's on line 25. So breakfast, let's do that. Sign. So maybe we could even do this. We could say return. Let's say return. All right. Let's try that. So what happens if I does it kind of help us out? Let's see here. Return. Yeah, I think that the typing is something that does screw me up sometimes. And I tip this is one of the ways that I get around it, which is random. Let's try that. Now again, I can look at my other example here. What did I do before? So I did Marco Polo string let logic. Yeah, so this is to me the biggest issue is you have to get past the compiler. So it says expected this but found string. Same thing breakfast, but expected struct. What if we said this? What if we try this? Returns. Yeah, for whatever reason, that returns fruit. That's not working. And we want to say this. You comment that says return that. I kind of try to trick Copilot into helping me out here. Maybe that's the issue. Okay. Two string edit. Okay. Two string. Yeah. think somebody may have helped me out here. So let's try that. Does that work? I don't know if that did work. Let's try this out. Expected one of these. See, because this should be string already. So there's some kind of weird type here that's causing a problem. That's interesting, the way that works. And we could say convert meal to we could convert meal to. Well, let's see what this does. Let's try this out. Sometimes you have to fight it, like when I get stuck here. Let's see. Oh well, I only have one error now. So it says no method named choose found for struct, and that's on line 18. Oh, so choose. No, not found. Well, first of all, do I really need async? Let's see if it can be. Let's see if I just take out the async stuff. Try that. Still have a problem. Format sequence. String is not a future. This recall. Oh, I see. And now that I changed it, I don't need to be. So I think the async stuff can be really tricky. I think that's one takeaway. There we go. So I think that's probably one of the takeaways is I'm not an expert yet on the async stuff, and I think that was potentially one of the issues. So in theory, this is working. So now I should be able to go to do the make run, and make. Let's see here. Let's look at the instructions. So we do the first thing we want to do is build the Lambda function. If you want to recommend as much as possible. So we want to just build the release. Let's just keep it real simple and let's just build release. We'll say cargo build release. We'll say make release. Make release. So in theory, if this works, that's a good sign. Yeah, the reason why this code is a little bit tricky, which is cool, and I just need to get up to speed on it, is that it uses that really fancy Tokyo library because the whole goal of Lambda is to be massively async. So, but again, in some sense, even when you struggle like that and you're like, hey, what's going on? What's going on? That's good because you actually are paying the price up front versus paying the price in production. Like if it compiles, you can be pretty confident that it's going to be a good time. So now I just do this. I just say cargo lambda deploy. And if we go here, so I just say make deploy. So I just say make deploy. Deploy. Verifying access. Now, if I wanted to set up an IAM role or something, I could do that. But because I've already hooked up my account via the extension from Visual Studio Code, you can see here it should be trivial. Waiting 10 seconds to redeploy. There we go. Whoa, that was easy. So look, we can double check it. So if we go to here and we go to Lambda, we should see mealgen. There you go. There's our mealgen. So how do we invoke it? I should just say meal, and we'll call this breakfast. So if I just say make invoke, let's try it out. Let's see here, data. Let's double check what the payload should be. Is it? missing name, line 1. Oh, field name. Let's look for name. Huh. Invoke meal breakfast. Oh, because I'm calling the wrong Lambda. I was like, wait, I thought Rust was so robust. How could this possibly fail? Because I have the wrong command. So I need to just type in mealgen. That will do it. There you go. Meal apple. And if I wanted to change it to be dinner, there we go. Make, invoke, steak. And then if we want to change it to lunch, right, we can see make invoke meal apple, right? It's going to randomly give us some stuff. So not bad. Not bad actually, all things considered. And if I go over to my README here, we can put this inside. We can say like, invocation here. But I think the trick here with Rust and Lambda is that it is true. Like I fumbled a little bit and everything, but I feel really confident once I get things compiled that this thing is going to be rock solid and extremely fast too. You saw the deploy is trivial to get working, and so I think it's a pretty big win to get Lambda cooking here, and I like how easy that was, um, and probably I can just stop there. I'll put a little bit of notes on what I built, and if anybody else wants to take a look at it. So if I just go through here, I can put some notes here and just say like, my main file is this, right? Oh, wow. Copilot is quite nice to me, right? Now there's a couple things I'd like to try in the future. Like I would be curious about building out a library, like having separate files. I'm also curious about third-party libraries. Although I did install the the RAND module, but I would be curious about things like Hugging Face, for example, or Onyx, or those kinds of things. So this is a good start, though. I think this is a good start to play around with lambdas. A little bit, a little bit of a bump in the road, but not too bad. And if I look at the code, it mostly makes sense to me. Again, the thing that trips me up always is like just kind of going back and forth, back and forth. Like, what am I doing until I get the formatting, the linting working? Once I get those working, then the compile almost always works because the linter is just so good. All right, so that's a good place to stop today. I'm going to go here and say get status, check this in, and commit this working mealgen for AWS, Lambda, and Rust. So not too bad. Not bad at all. All right, thanks for everybody that showed up. See you in a couple weeks.